Hey everybody, this is Alex Merced from alexmercedcoder.com with another video on Raku. I just realized I was reading the Raku documentation. Apparently this is so new that the OOP and functions part of the documentation is not written yet. It says to be determined. So I'll just kind of have to magically figure out how to write functions and do OOP. But we'll figure that out in a second. First we're going to do is show you what a do block does. Okay? So a do block is a block of code. You might be familiar with blocks from like Ruby. So you can have, do something like this. Say, oh, nope, I don't want to do that. So let's say I just create a block. And then since it's a block, I can, as long as I have semicolons, I can do a bunch of stuff in one line. So like say hi, semicolon, say bye. And this would work. Okay, this is all fun and good. See, hi, bye. You can do that. I could also do something like this. I can do a do block, which then I have an expression. So say it's true, and then that's if the variables. That's if true is this expression is true. The expression at the end of the block. Okay, if not, it's going to be like. So right now, let's just say it's true. Okay, now if I make it false, it won't do anything at all. It'll just skip this block. Okay, or at least it's supposed to. Let's see here. Unless use of constant integer false is in sync context. Let me think about that. I think it's supposed to be, I have to do like an or die. Okay. So that means that if this block is false, it'll die. See, it's true. It died. Oh wait. It's true is always going to happen. So let's see here. Is it true? Technically, this part always runs. Then it's going to evaluate this or die. And then I think there's another block here. Say it's true. Okay. Now if I run this, see the it's true part never runs because it just kills the program right there. Okay, and if it's true, then it continues running. Okay. Again, sort of a silly thing. I can't imagine when I really just want to kill a process. But I mean, I can imagine if you have multi-threaded processes, there's situations where you might want to just kill a process. So you say, hey, if this thing is no longer this thing is not true, kill the process. So that's a thing you can do. There's also switch statements. So let's see here. Let's say name my name equals Alex. Okay, and then we'll just do switch name. Okay, and okay, so switch name, then curly brackets, and then here we can do the different cases. So if it's case Alex, then we'll just say my name is Alex. And break. And if it's anything else, we'll have a default case. And not my name. We want to say that. Say not my name. Put a break there just in case. Okay, so right now my name is Alex, so let's see if this works. Okay, boot, 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 boot. So block in fixed position, missing statement control word before the expression. Didn't want switch. I think what I need is parentheses here. Name. Let's try that. Let's get rid of some of this extra space here. forward. Oh, I'm doing JavaScript syntax. Okay, because one of the cool things I really do like about the Raku documentation is that depending on what language you're most comfortable with, they have a set of documentation that says, okay, this is how you do it in this language, and this is how you do it in Raku. So like this is the JavaScript version, this is the Raku version. I read a little overzealously, and this is the JavaScript version. I was like, this looks pretty what I'm used to. But no, it's more like this. Okay, you're going to use when. So essentially it's a do block. So basically the way it'll work, say here, do given name. Then we do this. And then here we have a bunch of when blocks. So when, and here it actually makes sense why you would want to do a when block, because the minute one of these switches are true, you don't want any of the following ones to be. So when name equals Alex, and since it's given name, it'll automatically check against name, so I can just do when Alex. So when name is Alex, say my name is Alex. When Bob say my name is Bob. Okay, so in this case we're given name is Alex, should match up with this. Run this when block, which means it'll not do anything else in that block, so the rest of the block is done. And that should, let's see here, stop. Compiling. It's taking its sweet time. Let's try it again. I think I need semicolons. Colons here, and then this also just this block will actually just return it. So what I can do is I can say do given any name, so this block will return my name is Alex, and then it'll say that. Let's give that a shot. I have to refresh this. Let that refresh. Oh, okay, so it didn't save any of that. So we'll have to do that whole thing again. So so we want to print, but it's going to be based on this block. Name. Okay, when Alex my name is Alex Merced. And let's see how that goes. And see, it works. Now let's see if I did another when statement. When Bob my name is Bob. Okay, I should still come up with my name is Alex Merced, because right now the name is not Bob. Okay, sorry, error missing block. Oh, yep, I see. There we go. Now if I change Alex to Bob, my name is Bob. So essentially that is the way you would do a switch statement. Again, the way this reads is this will return the value of the block, of the when block that's triggered. So it's saying do given this variable which when block triggers. When you find the when block that triggers, leave that block, return me the value of that, the block associated with that when. So that's kind of weird. Not quite the same as your traditional switch, but you can do some cool stuff with that. Actually, I kind of like that syntax. I kind of like how that works. I think that's pretty cool. Then you got enums, okay, where you can create, like, let's say a heads or tails. So like enum, coin flip equals, I think it's like heads, tails. Okay, so then if I make a new variable, my coin flip equals heads. Okay, and I think I can type that, yeah, possibly. Well, let's take a look. So yeah, no, I can type this variable. So type coin flip, and we'll type it coin flip. So basically, it'll expect one of these as the answer, and then we'll just say coin flip and see how that goes. And then we need a multiply an expression using, okay, because I didn't need this comma here. You just should be able to separate them by spaces. Let's try that again. While cleaning, enum must apply an expression using, which we did, enum coin flip. Actually, I think I don't even need the equal sign. Compiling, variable coin flip is not declared. Did you mean coin flip? Oh, that's right. I guess the type goes first. So then technically this is the variable. So let's try it. Or I can just do this, because I'm assigning it anyways. There you go. Because see, notice I didn't have to put quotation marks around heads. Because even though heads is not a string, because I didn't use quotation marks, it recognized it as a valid value of the coin flip type. Now let's say I did this. Let's just call the variable flip, and we type it as coin flip. And then that's that. And then I do flip equals heads. And then we say flip. Again, this will be allowed because, again, heads is a proper value of, is one of the two possible options of the enum. Okay, variable flip is not declared. Okay, so I guess it is the other way around. So let's just restate that. Coin flip flip. Okay, so the flip is the variable. Okay. Still doesn't like that. Why? Because I'm thinking TypeScript. Okay, I don't need this colon here. So it's my coin flip flip. There we go. And see, so basically I declare it, and then see it allows heads because it realizes it's a coin flip type object. Now let's say I did something like this. Shoulders. Shoulders is not defined anywhere as a value of anything. So if I do this, I'm going to run into an error. See, error 1, compiling undeclared name. It's like, what is shoulders? Okay, because none of the types that are defined have a value of shoulders. So enums allow you to define types. If you have some sort of piece of data that you're going to be using a lot that always has the same values, and you don't want people assigning anything other than the values you want assigned, enums can be very helpful. Like a coin flip shouldn't be anything other than heads or tails. So instead of using a string, and someone can just assign any kind of string they want, I'm hard coding it that it can only be heads or tails. Okay, so that's what we've covered in this video. So we talked about switches, which are really given blocks. We've talked about enums, which are a way of defining types in Raku. And I will talk to you guys more in the next video. Have a good one.